Hi, I'm Duke Southard, owner-operator of Southard School of Racing. We're based in New Smyrna Beach, Florida. We're doing a video today. We're going to actually do two videos. It's going to be we couldn't get it all on one video, so we made two videos. This one's going to be on building the ultimate short track motor. This motor then being in the $12,000 to $20,000 range. I'm in Mr. Bruce Baker's shop, who is in DeLand, which is about 20 miles west of New Smyrna Beach. We're going to be doing the video here in his engine assembly room. This is one of the engines he's built for one of the NASCAR champions, and in the last 2 years the engine's won about 20 races. This happens to be a dirt motor, but we're going to be talking about dirt and asphalt both. We're going to be talking about engines in the cubic inch range from 3 to 420 cubic inches in that area. The very ultimate motor. We're not going to be talking about the stock parts and everything like that. We've got another video that takes care of it. If you're going to build the economy motor, this is not for the economy-minded person. This is for the person that wants the ultimate motor. This video can be ordered through Southard School of Racing only. Mr. Bruce Baker and John are going to be here doing this video for me in the two phases, and I'm going to kind of do it like I've done my other videos. Is I'm going to step back out of the limelight, let them get in front of the camera, and let me ask them questions that I think maybe that you would ask, and maybe let them ask each other questions that you would ask, the things that they hear most on the phone. But we want to mainly in this video teach you how to select your parts, what to do with them before you put them on, how to maintain them after you put them on, and upkeep, how to set your lifters. We're going to do a lot of things in this video that the other videos have not ever covered, and a lot of stuff that the books haven't covered. So this is the ultimate short track motor for Chevrolet. Bruce, why don't you come in and introduce yourself?
Hi, I'm Bruce Baker.
Hey, Bruce, how long have you been building engines?
9 years.
How long have you been here in DeLand building engines?
3 years.
About how many engines do you think you've built over your career?
900.
And about how many since you've started building on your own?
150.
Okay, what about winning engines? You got any persons that you might tell the people that you've built engines for?
Steve Grissom won the All-Pro Championship in 1985. Tuck Trenn's won the points the last 2 years at Volusia County Speedway.
Okay, so you build a lot of dirt and asphalt engines.
Yes.
I know that you've moved here to DeLand just recently into a new shop here, and you've got a new partner. Why don't you introduce your new partner?
Partner John Kaiserman.
Hi, my name is John Kaiserman. I've worked approximately 11 years in the automotive machine shop industry. The last 3 years I've been working with Bruce Baker. We build and develop small block Chevrolet engines, both asphalt and dirt, low compression and high compression. We're going to go over some of the techniques, steps, materials, and parts that you're going to need to build and maintain an engine such as this one here. This engine being a 388 cubic inch Chevrolet. It's an alcohol motor. You can see it's dry sump lubrication. It has a belt-driven fuel pump, an alcohol carburetor, and this engine is also equipped with a power steering pump. It has a magneto for ignition, and we're going to go over all of these components as well as what's inside this motor, in this being part of a 2-tape series. The first piece we're going to cover today on building our ultimate short track motor is going to be the block. This is the house that all the parts are going to be put into, and we have to start with the correct piece that's going to hold the amount of horsepower we hope to build out of this engine. The correct piece to use is General Motors bow tie block number 366287. It's currently available from General Motors only, and a few aftermarket high performance companies do handle them. You will not find this block in a wrecking yard or a salvage yard or in an old truck. This block is made by General Motors. It's strictly from racing, and it's nothing that you can buy and take home and machine in your backyard. It takes a competent machinist, and there's going to be a lot of things we're going to cover on this block. The first thing, when Bruce and I get one of these blocks out of the crate, we put it on an engine stand, and it comes from Chevrolet with cam bearings in it. We remove these cam bearings, and then we take a dial bore gauge and we measure these housing bores. Sometimes at the factory these housing bores are not round, or they do not have the adequate crush fit for the bearings, and your cam bearings may come out of the block. what we'll do is measure the block, and if the crush is there, we'll put in stock cam bearings. If not, we have to start out by align boring the cam bearing journals and put in oversized cam bearings. Once we determine that this part of the block, then we go ahead and look over the rest of the block for any visual defects. Maybe there might be a broken off drill bit in the block, there might be a broken off tap, maybe there's some head bolts that haven't been drilled and tapped. All kinds of little funny things may arise. Once we determine that there's no such defects that way, we start by giving the block a general deburring. We deburr the lifter galley, the time and cover area, as well as in the crankcase. You need to spend a little more time in the crankcase radiusing these areas in the block which may cracks develop from. There's 3 on this side that are short, and then you will have 3 long ones to radius. This is, like I say, to eliminate a riser where a crack may start. After doing that, you also want to make sure to grind enough material off of this boss right here where the timing chain will adequately clear. And if you're going to run a 4-stage dry sump oiling system, you also have to grind this piece off the block right here around this bolt hole. Now, a lot of people ask me, how long does it take to grind a block? You can expect to spend 2.5 to 3 hours to do a nice job. Like I said, it doesn't have to be a mirror finish. You just want to knock the surface down so the oil will drain back quicker, and it makes for a little more professional prepared piece. Now, after we've done that, we'll run the block through the hot tank and clean it off because it's quite dirty after all these grinding operations. And we're going to set it up in the milling machine, and we're going to eliminate the Chevrolet straight main caps. We're going to go to an aftermarket steel cap, which looks like this, which is far superior to the conventional stock caps like this. And the reason why, if these angled bolts, they don't really tie the block together so much as they keep the main caps from drawing in. Now this main cap sets in your race car like this, and when you have the load coming down on the crankshaft, it's trying to draw the caps in, and these angle bolts help hold the cap out like this.
What brand are those, John?
These caps are manufactured by Oliver Machinery. You can also buy these caps from Howard Stewart Engine Components. They're also available from Diamond Racing and Beau Laws. At the end of the tape, we're going to list a lot of these manufacturers and suppliers of these aftermarket parts. This takes care of the center 3, and on the end caps, we take the end cap and we're going to machine it off flat in the mill to where it's going to look like this, and we are then going to put what we call a main support on top of it, and this is going to support the cap. It's kind of like a truss. Now, a lot of people don't go through this. They run the stock cap and they may wind up with something like this when they tear their motor apart.
Who makes the supports?
These supports are also available from Beau Laws Automotive, Howard Stewart, Golden. We're going to go over, like I said, at the end of the tape and give you where these pieces are available from. On your rear main bearing cap, we're going to do the same thing. We're going to machine it off to where it's going to look like this, and we're going to put a rear support on it. And believe me, I've seen front caps break, rear caps break. There's a broken rear cap. Once again, here's the broken front cap. And here was a broken center cap. And we have found these caps on engines that were just brought in for rebuilds, and the people didn't even know it. They were very lucky. After we install these caps, the block needs to be align bored and then align honed. And the reason why I say align bored and then align honed, the steel caps are smaller than the factory size. They have to be bored out, and then we like the honing for the finish. You have to have a smooth finish on your housing bores so that the bearing will have an ability to transfer heat out of it. A lot of people didn't know that, but the bearing, not only does it support the loads of the crank, but it also must be able to transmit heat. And if you have a poor finish, the bearing may run hotter than normal, and it may damage the bearing, and we know what happens from there. One other thing is we always use studs. We don't use any bolts in our motor. The reason being, they offer better clamping, and on several rebuilds, if you kept torquing these bolts in and out, eventually you would strip the block, and we don't want to do that. After we have the caps on and the block is line honed, we're going to run it back through the cleaning tank one more time and get all the oil off of it. And then we're going to bring it to our decking machine and we're going to deck the block. Now Chevrolet has left quite a bit of additional material on the deck surfaces. And we have special fixtures so that we can we can deck this surface so that it is parallel to the crankshaft, and that when we are done it will be 90 degrees to this deck, and it will be 45 degrees to the cylinders. Now, not many people have this type of equipment. This is something you'll have to have done outside, but it has to be done.
What brand of fixture do you use?
All right. On this block here, BHJ Performance Products manufactures all the necessary components for machining these bow tie blocks. They have the bore true fixtures, which we're going to talk about. They have the block true fixtures, which is the pieces we used for decking the block. Now, when we deck our blocks, you have several ways to do it. You can pre-assemble the engine and measure how far the pistons are in the hole and cut the block accordingly. But when you build as many race motors a year as we do, we build all our engines at what we call a 9-inch 5/1000 deck height. In other words, from the center line of the crank to the deck of the block, if you can measure this, we make it 9 inches and 5/1000. Now, before we deck the block, this isn't anything that is absolutely necessary for the bow tie block, but we do like to tap these 3 holes up here and screw in pipe plugs. Now, these do 2 things. They do add some strength to the deck of the block, but more importantly, they help restrict the water flow. And if you're going to run aluminum cylinder heads on this motor, you need to drill approximately a 1/4-inch hole through these plugs. If you're going to run steel heads, all 3 plugs must have a 1/4-inch hole. But with the aluminum heads, only this center one. Now, another thing you should do with this block while it's in the decking machine is tap every one of these bolt holes with a bottoming tap. There's room enough for about 1 or 2 more threads down there in the bottom, and when we put our cylinder head studs in, we use red Loctite, and you want to make sure that the stud bottoms out on its shoulder of the last thread and not bottoms out in the block.
What do you torque them to?
We normally torque the studs in to approximately 15 foot-pounds. These holes are blind holes. They do not go into water, so you don't have to worry about them leaking water. So, like I said, tap them out with a bottoming tap, blow them out, and when you put your studs in, use red Loctite and torque them in approximately 10 to 15 foot-pounds. Now we're going to get on to boring the cylinders. BHJ has made a fixture to bolt onto the deck of the block that's going to locate the cylinders. Now this block, as it comes from Chevrolet, has a 3.950 bore. Now, as most of you know, a 350 Chevrolet, the 327 Chevrolets all have a 4-inch bore, so you have plenty of material to remove. And these blocks, they're mass machined, and the bores are quite rough, so this BHJ fixture is going to allow us to space each cylinder directly over the throw of the crankshaft, and it's also going to space the cylinder up and down to where all the cylinders are in a line. And now all the cylinders, because we have decked the block with the BHJ fixtures, all of the cylinders are going to run parallel to the deck of the block. Now we're going to leave approximately 5 thousandths of material in the block to hone out. We'll take the block over to the Southards. A lot of shops have the CK10. The newer shops may have updated to the Southards CV616. Both machines will do a more than adequate job. We'll hone the blocks, and we'll wind up our finish hone will be with a JHU 825 stone. This stone will take care of all of your moly rings. We don't use any chrome rings in our dirt motors. We're going to go over rings later on, but we use the JHU 825 stones for finish. We've experimented with other finishes. We just didn't see where the additional work, we didn't really get any gains, so we've just quit there. After we've honed the block, we run it back through the hot tank one more time, and then we bring it out of the hot tank and let it cool. And because these are new blocks, they dimensionally change on us. And while the block is dry, we're going to spend some time drilling out our holes for our dry sump oiling and a few other small modifications. We're going to start out, we'll take the steel caps off the block, and we're going to drill the center 3 mains out. These holes here, they're approximately 1/4 inch in diameter now. We're going to drill them out to 5/16 of an inch. You want to drill all the way through the main bearing bulkhead and all the way through the cam hole, the housing bore, and into this main oil galley right here. Drill all the way through with a 5/16 drill bit. The next thing we're going to do is...
John, before you go any further, is this going to require when you put the bearings in that you drill them also?
Yes, we're going to go over that, Duke. We're going to drill the bearings out to match these holes in the block, and we're going to show you a few other little tips about the bearings when we get that far along. We're also going to deburr these holes, just the leading edge. You don't need to get carried away, just break the edge. These 3 holes in the front of the block, Chevrolet has just machined them for a press-in plug. We don't want to do that on a race motor. We're going to tap these and install a 1/4 inch pipe plug. Now you want to be very careful with this center plug right here so that it will go in and be flush, but when you have this cam bearing out, you want to make sure that this plug does not go in so far as that it's going to cut oil off to this front main. This cam bearing oils this main bearing, and if this plug is run in too far, it'll cut that oil hole off. So before you put this cam bearing in, and we're going to go over a cam bearing installation, be sure and put this plug in first and make sure that it doesn't cut that hole off. These holes here, just tap them where the plug will screw in approximately flush. You won't have any other problems. And remember, I said if you're going to run a chain drive, make sure you grind this area off so that the camshaft, or excuse me, the timing chain will not drag the block here. Now, like I said, we're going to run dry sump oiling. We do not run the filter here. We run a remote filter. But if you would like to run your filter here, that is perfectly okay. But you need to drill and tap the block right here for your number 10 fitting. And I'm going to show you one of these fittings that we put in right here. Now, if you're going to plumb the motors the way we do our motors, we plug this hole right here, and this hole down in here also must be plugged.
Could you move that engine around so we can see
Yeah.
that?
You're going to have, plugging this hole isn't going to be a problem. You can readily get a tap in this hole and tap it and plug it. Now this hole that's back in here, you're going to have to go through this hole here, and you'll have to drill this out to approximately 3/4 of an inch, and then you'll be able to go back in there and tap that hole out. Now don't put any of these plugs in yet. These will be in for final assembly, but make sure that the plug will go in at least till it's almost flush, because you don't want these things coming loose. The next thing we have to do on the front of the block, see how much noise I can make here turning it around for you. This is where we run our main oil feed into. This oil feed hole we drill out to a 1/2 inch in diameter. Now you don't need anything more than a hand drill and a little bit of patience, and you can very carefully enlarge this hole to 1/2 inch. Then you need to start out with a 9/16 drill bit and drill approximately 1 inch down in there, and then tap this for a 3/8 pipe fitting. Now the reason why we like to plumb our oil in here is this gives a direct shot of oil to the mains. The oil is going to come in here and it hits your main oil galley. It goes from the main oil galley behind the cam bearings. When you have the cam bearings out of the block, you'll see that there's a groove in the block. The oil comes from the main oil galley behind the cam bearings and directly to the mains. If you plumb your oil in like Chevrolet has done it with a conventional pump, or if you choose to use your remote filter, your oil must go in through the filter. It's going to come across the back of the block. It's going to then come up and intersect this hole right here. There's an oil galley right here. This oil galley goes straight to the rear main cap, and then it is connected to your main oil galley by this hole drilled right here. So your oil, it spends a long time before it gets to the main oil galley. Plus these holes are various sizes, and there's a lot of restrictions and corners they must take. So we just like to come directly out of the oil pump. We're going to run it through a remote filter, and we're going to plumb the oil right into this main oil galley. And your engine's going to get direct oiling to the mains. After we've done all of this, we're going to measure the housing bores one more time on our mains. With the steel caps, remember, we've taken them off now. I'm going to give them a bath, clean them up, dry them off. I'm going to bolt them back on, and I'm going to probably have to touch up the housing bores. The mains will generally tighten up maybe 1/2 thousandths. They might even go as much as 1/1000th. But we're going to touch them up now.
What size are the housing bores?
All right, we align hone all of our blocks to 2.641½. Now, if you look in a service manual, you'll find that Chevrolet lists the housing bores to be 2.6405 to 2.6415. And I'll write that down for you. Now the reason why we align hone our blocks to the 2.6415 is when we're dealing with our race motors, 9 out of 10 of them have brand new crankshafts. And by going to the maximum housing bores, we can generally get our desired clearances with standards or 1-under bearings. And we're going to go over how we check our bearing clearances and how we can juggle standards and 1 underbearings to arrive at our clearances. But once I know that my main caps are back to 2.641 and a half.
What do you torque them at? Enters in the outers.
All right. When you buy your studs, they're going to recommend their torque specifications. We run our studs at 65 foot-pounds on all the main bolts, as well as the cylinder head bolts. And don't just put the caps on there and throw the washers on and torque the nuts down. Put a little oil on the washers and put some oil on the threads. They need a little lubrication on them. You don't want to run them down dry. But we run head studs and main studs at 65 foot-pounds. That's even for the outer bolts. Now, we're going to take our block and we're going to run it through the cleaning tank one more time. We're going to bring it out. We're going to dry it. We're going to look everything over, make sure that we've gotten everything done that we want. And last of all, but not least, we're going to install screen kits in these drain back holes. You have 2 holes in the front. You have 2 holes back here. Now you can make your own screen kits. You can make them out of brass screen, or you can buy screen kits that are manufactured by, I believe Moroso makes a pretty nice kit. And it's also going to give you 8 pipe plugs to plug these holes off with right here also. Now, we recommend if you plug these holes off, we like to drill an 1/8 inch hole so they can drip oil through them for a little additional oil drainage, plus it'll put a little additional lubrication on the camshaft. A lot of people just put the plugs in without drilling holes. This is okay, but this is what we prefer. We then take the block, paint it, we'll wipe the decks down with thinner, we'll wipe the cylinders down, and a lot of people ask us about washing the blocks in soap and water. That's fine. We do that, but we also like to take, when we're all done with our last cleaning, take a very lint-free rag with automatic transmission fluid and wipe the cylinders out. And you'll be surprised how dirty the cylinders still are. That Honan grit really likes to stay in there. So last of all, wipe the cylinders out with automatic transmission fluid, and now we're ready to start assembling the block.
John, I'd like to clarify one thing. You said paint the block you were talking about externally. You do not believe in painting the inside of the motor?
No, sir. We don't paint the inside of the motor. If any of that paint was to come off, it could go through the filter, or it could go through the oiling system. It may get past the filter. It may plug the filter up. It's just not worth it. The best thing, the reason why people painted the inside of the block was to get away from deburring the block. Now, if you don't feel that deburring the block is that necessary, at least hit the high spots, any slag you may find in the block, and you know, clean the block up that way. But I wouldn't recommend any paint inside the block. We generally paint our blocks after, when they're on the engine stand. As a matter of fact, for your interest, we paint all of our pieces before we bolt them together. It just makes the motor look a little neater and a little more professional.
John, tell them about the other blocks we use.
All right, in addition to this bow tie block, rules permitting, we'll use an aluminum block. Now this is going to add about $2,500 to $3,000 to the cost of your motor, but this block, at least when you take it out of the crate, it's fully machined, ready to go. The only ones that we have used have been from Rodeck. It's a very nice piece. It has 4-bolt angle main caps on all 5 positions. The block is already honed, it's decked, it is ready to go. It comes with cam bearings, screw-in freeze plugs, all your restrictors. It's a race-ready piece. And one other thing I'd like to cover, sometimes we build the bigger cubic inch motors in the 428, 435 cubic inch, where we'll use a 400 Chevrolet block. And the only big difference between the 400 block and this block is the 400 has a larger main size, which when you order your crank, if you're going to use a 400 block, make sure you get the 400 main size. And when you put your cylinder head studs in a 400 they go into water, so make sure you have them sealed with Loctite real well, or use your blue Permatex or some type of silicone, because you don't want water leaking past the threads. And the steam holes, we recommend you plug them, and there's no real trick there. You can just tap them and put in a small set screw. And one last thing, when I was going over all of these machining operations on this bow tie block, it takes approximately 16 hours to do all this machine work, so don't try to get in a big hurry. Take your time, because if your house falls down, and we call the block the house of the motor, if the house falls down, it's going to destroy all the parts inside.
In this part of the video, we're going to be talking about crankshafts. John, tell me which one do we use?
Currently, we're using 2 crankshafts in our motor. The first, I've written down your material being a 5140 crank, which is this crank, or the 4340 jet crank. And the way to identify one or the other, the 4340 jet crank will say jet on it, where the 5140 crank will have this casting number 6280 on this very first throw, or first counterweight. Now, how we determine whether we're going to use a 5140 or the 4340 will be by the cubic inch of the motor. We generally reserve the jet cranks for our big cubic inch alcohol burning motors, and we use the 5140s for our asphalt and smaller cubic inch dirt motors. The next thing I want to talk about is stroke. And naturally, you all know that stroke has to do with the cubic inch of the motor. So depending on whether you're going to build a 331 motor, a 355 cubic inch motor, a 388, a 377, 400, 402, whatever cubic inch motor you're going to build, you're going to have to determine your stroke or your bore size. Now, for those of you that do not know how to determine the cubic inches of the motor by bore and stroke, at the end of this video, or somewhere in this video, we're going to list the formulas for figuring your cubic inches, and we're going to give you some of our bore and stroke combinations in building the motors.
What you talking about when they order the cranes, they get the right rods, have their journals cut down for like 585 or 6 inch.
That's correct. What Bruce is talking about is the actual counterweight size. We're going to skip a couple of things here, but this counterweight size. When you have a connecting rod attached to the crank, and when you have the rods, they'll have the rods and the pistons in the block, and you rotate the crankshaft counterweights must clear the pistons. And depending on what length rod you use will determine your counterweight size. So if you're going to run a crankshaft with a 5/7 length rod, you're going to have to specify that the counterweights are machined for a 5.7 inch rod. If you're going to run a 5.85 length rod, as this crank is, it is stamped right there that this crank has been machined for a 5.85 length rod. Now, if you run a 6 inch length rod, the counterweights will clear. Currently, when these cranks are made, they are made for a 6 inch rod motor. So you only need to specify if you're going to run a shorter rod. Now, getting back to the main size and throw size being the mains, and we call these the throw. We generally specify the mains on the 350 size cranks to be 2.448 to 2.448 2/10. Now, if you have your housing bores at 2.641 1/2 like we talked about earlier, and have this main size of 2.448, you will run approximately 3/1000 main bearing clearance. And incidentally, we like to run these motors between 2 8/10 to 3 2/10. Now, you cannot run the motors any tighter. If you have to go to 3.5 clearance, that's okay, but do not run the motors any tighter than 2 8/10. Now, I've written down counterweights. A lot of people ask me, do I need a fully counterweighted crank or do I need a conventionally counterweighted crank? Well, the only thing I can tell them is a fully counterweighted crank may be a little better suited for a super speedway application. It adds a little more rigidity to the crank, and where a motor runs, say, a constant 7,000 or 8,000 RPMs all the time, it does make for a little stiffer crank. And on a short track application, I would stay away from the fully counterweighted crank because of its weight. And that's one thing that we're concerned with, is this is a rotating mass inside your engine, and the lighter these components are, the quicker the motor will accelerate. And last of all, but not least, the bearings. We recommend Michigan bearings. These bearings come to us already pre-chamfered on this side and pre-chamfered on this side. Now, the reason why they're done that way is to clear the larger radius that is ground into these cranks. These have what we call 150 thousandths radius journals. This makes the crank a little stronger. And the only thing additional we do to the bearing when we take it out of the box is this oil hole must be drilled out to match the oil hole in your block. We then take a small chamfering tool, chamfer the oil hole on both sides, and then take a small round file and do any additional deburring. And then we will install the bearings into the block and do our clearances. And once the bearings are all clearanced properly, we take them out. We put the bearing location number on the back of the bearing. I don't know whether you can see this, but we'll put a small number there with an electric pencil. Then the bearings are washed and they're Scotch brighted. Now, the Scotch brighting, it does two things. You're removing a coating that is put on this bearing at the factory that protects it from rusting. And that coating is on both sides of the bearing. So you must Scotch bright not only this side, but do the back side as well. Now, this also gets back to the part about the bearing being able to transfer heat out of the motor. So these surfaces have to be clean. And I can't overstress how clean these bearings have to be. But anyway, like I said, we use the Michigan bearings. The main reason being they're chamfered from the factory, and the only additional work we have to do is drill the oil holes out. And we're going to talk about the rod bearings when we get to the rods.
John, give us two sources that we prefer using.
These crankshafts, you can buy them from Hank the Crank. You can buy them from Moldex. You can buy them from BRC. Those are some of your major crank suppliers. You have to understand that the 5140 forging or the 4340 forging, it doesn't matter who forged it. This crank comes from GM, but it is finished by Hank the Crank. This crankshaft right here happens to be finished by BRC. So the material, it doesn't matter who you buy it from, the material is the same. A 5140 crank is a 5140 crank, and a 4340 is a 4340. We prefer to use Hank the Crank or BRC or Moldex.
On this part of the video, we're going to be talking about rods. Type and style, length, preparation, bearings, recommended clearances, and pin clearance. All right, John?
Okay, in most of our motors, we have been using the Carrillo rod, and this is an example of it right here. This rod has been around longer than I have. It's made in California by Warren Industries. It's probably the state of the art and the best thing going. Another type of rod we use a lot of is a Crower rod. It's also made in California, and by the way, these are all steel rods that we use in our motor. We don't use any titanium or any aluminum rods. And another rod that we use a lot of, unfortunately I don't have one to show you, is an Oliver rod that's manufactured in Michigan. The Oliver rod looks almost identical to a Crower rod, with the exception where a Crower rod has a wasted through bolt. The Oliver rod has a stud that is threaded into the rod, and then it also uses nuts to hold the cap on. On the length of the rod, we always use 6-inch rods. We don't use any 5/7 rods. On some special applications we have used a 5.85 length rod, but as far as over-the-counter pieces that are readily available, and I'm not talking just so much about the rods but the pistons, because whenever you run a shorter rod you have to have a different wrist pin location in the piston. The 6-inch rods and the pistons for 6-inch rods are more readily available. As far as preparing the rods, when we get them out of the box from Kriller or Crower or whoever, we disassemble the rod, take the bolts out, and clean the rods off in our safety clean machine, clean all the bolts, and dry them. And I'm going to take these bolts out now. And the rods are all cleaned and then reassembled. Now on Carrillo rods only, when you reassemble them, they have a special grease that they recommend you using on the bolts. Now on all other rods we're going to use 50 weight engine oil, but on the Carrillo rods be sure and use this grease on the bolt. Now after we retorque the rods, we are going to measure the housing bore in the rod to make sure it is round and of the proper size. Now when these rods are new and you take them apart and put them back together, they'll change a little bit, so that's why we take them apart, clean them, and put them back together and touch them up. Now when we recondition these rods, we're going to hone them to 2.2250, and I'm going to talk a little bit more about that in a minute. The next thing with the bearings that we run, as I mentioned with the main bearings, we use Michigan. We also use Michigan rod bearings. And probably the biggest reason is the bearings are chamfered to match the chamfer in the connecting rod. Now this chamfer rides against the throw on the crank. And if you didn't have that chamfer in there, the bearing will drag the throw or drag the radius in the throw, and it may cause the bearing to burn out and spin. Now, about the clearances. Like I said, we resize these rods to 2.2250. Now, as you remembered, I told you we would order our crank size 2.0990. If you will take a bearing mic and measure the shell thickness of the bearings. Now every bearing may be a little bit different, so we checked each and every bearing. These bearings that I happen to have today, the two bearing shell thicknesses are 123 6/10. Now that's for two bearings. Each bearing is about 61 8/10 thick right here. I will subtract that and I come up with my 2 9/10 thousandths clearance. And we recommend 2 8/10 to 3 2/10 clearance. These are clearances that we have used for probably the last 3 or 4 years, and the bearings always look real good, and we maintain good oil pressure, so we haven't tried anything else. On our pin clearances, when you get these rods from Carrillo or Oliver or Crower, the bushings are generally left a little small so that you can finish honing them to size. And we prefer brand new out of the box. We'll set our pin clearance at 1 4/10. And we will continue rehoning this bushing on rebuilds until it reaches 2 thousandths maximum clearance. At that time we will change the bushing. Now one other little small thing, from time to time we have found that they have forgot to drill the oil hole through the bushing. So when you get your rods out of the box or whatever, look and verify that they have drilled the oil hole. Now, Carrillo drills theirs from the bottom. Crower and Oliver both drill their oil holes from the top. Now, we haven't experienced any failures in the lines of bushings, whether they were drilled in the bottom or the top. So, the only thing I can tell you is if you do run these clearances, I think you'll find your bushings will hold up quite satisfactorily. Is there anything else we need to cover?
How about the press fit rods?
All right.
Don't we use those?
On occasions, we do use press fit rods. There's nothing wrong with it. The only thing, it becomes a little more difficult for the guy out in the field to dismount his rods. If he needs to change the piston or whatever, it becomes a little more difficult. But there is nothing wrong for people like you out there that may like to use press rods. Now, on some occasions, we might have some pistons with damaged wrist pin clips where the spiral locks fit in the pistons, and rather than throw away the pistons, if the pin bores are in good condition, we'll go to an oversized pin and we'll press the pin in the rod. But that's only in an emergency type repair, but there's really nothing wrong. As a matter of fact, I know of 1 or 2 major engine builders that use press pins exclusively, and there's really nothing wrong with it, other than it does become a little more difficult at your shop to dismount your rods if you have to change a rod or a piston or whatever.
And the clearances are basically the same on the piston.
Yeah, we're going to cover the pin clearance when we get to the pistons. We're going to run them a little bit tighter in the pistons, but we're going to cover that plus the pin walling when we get into the pistons. Now, one thing I want to point out to you on these bearing clearances, we've showed you how to do it mathematically here, which is how we do it, but we also double check all our clearances with a dial bore gauge, and that's just being safe. We like to double check everything. If Bruce assembles the motor, he'll check the clearances again, and when I assemble the motor, I recheck the clearances. And a lot of people think we spend a lot of time, or too much time, but clearances are so important. I can't overstress how important it is to double check, because it doesn't cost anything to recheck the clearances in the shop, but the motor goes out in the field and the guy runs the motor maybe 1 or 2 races and loses a bearing. He's going to feel bad. It's going to make you look bad or make us look bad, and it doesn't take any amount of time at all to double check. And if in doubt, call us or call someone that can check it for you. Don't just assume that your clearances are correct just because the box said it was a standard bearing or if it's a 10 under bearing. Just take your time, because the bearing clearances are probably the most critical thing in the engine.
And also, you should mag your rods when they're new and also on rebuilds.
That's correct. When we buy our rods and our crankshafts brand new, we try to magnaflux them, and we definitely magnaflux the rods at every rebuild. And one thing I didn't talk about is the rod bolts themselves. Now, the Carrillo standard Carrillo rod comes with an H11 tool steel bolt in it. And this bolt torques to 65 foot-pounds with the Carrillo assembly lube or grease on it. Now, we recommend replacing these rod bolts after every second rebuild. They're approximately $135 a set, but when you talk about the cost of a new motor when one of them breaks, it's cheap insurance. If you want to step up to a little better bolt, Carrillo has this bolt. It's called their SPS car bolt. And this bolt can be easily identified because it comes with a washer. These bolts are also torqued up with the assembly lube to 90 foot-pounds. These bolts can be used practically indefinitely, but they're almost $500 a set. So that's why you'll see Carrillo rods advertised at different prices. So if you're buying Corilla rods, you might want to find out if you're buying rods with the SPS car bolt or the H11 tool steel bolt. And one other little thing before
Just tell 'em
closing.
about the crank clearance, cam clearance.
That's correct. Now this particular rod here, this Corilla rod, we're using it in a 428 cubic inch small block motor. And the rods come extremely close to the camshaft. As a matter of fact, they'll hit. And we have ground this rod. You can see how the standard side looks from Corilla. We have ground this rod to clear the camshaft. And when you do this, you must have the cap and the rod bolts in the rod, because you're going to grind the bolt off to where it will match the chamfer on the rod. And then we number every bolt so that it goes back in its proper location.
And make sure they're torqued up when they do it.
That is correct. You want these bolts torqued. And normally, if we know that we're going to have rod to cam clearance, when we pull this rod out of the box, before we do anything to it, we'll grind it, because you want to try to keep from getting the rod overheated, but it will distort the housing bore a little bit. So we'll grind this rod to clear the cam first, and then we'll go on to our clearance procedures. And one thing I didn't cover earlier in the block preparation, the bow tie blocks have adequate rod clearance in the crankcase up to a 3.5 inch stroke motor. If you're going over 3.5 inches in stroke, you're going to have to check your rods to make sure they clear the block. Now, the Oliver rods that I talked about earlier, those rods will clear the block up to 4 3/4 inches of stroke. And when you order your rods, you can also have this clearance cut into them for the camshaft at no extra charge. And I think that's about going to cover it.
This part of the video we're going to be talking about pistons. Types and style, preparation, pin bore, which consisted of A and B of oiling and clearance, spiral locks, skirt clearance, and maintenance. Alright, John?
Alright. First of all, most of the pistons that we use as far as types and styles, they're going to have a dome on them, because most of our motors that we build are alcohol burning dirt motors, as well as gasoline dirt motors, which run what we call unlimited compression. Now, we don't order a 12.5 to 1 piston or a 13 to 1 piston, because the compression isn't all in the piston. It has to do with the type of head you run and all, but we're going to show you how to figure your compression ratio. But we order a dome piston. This particular piston here happens to come from J&E. Now, I also have here, this is a diamond piston. It even has some rings on it. And we use a lot of Wiseco pistons. We primarily use the Wiseco pistons in our 9 to 1 compression asphalt motors. These pistons, 9 to 1s being flat top, 2 eyebrows in them. And we've used, I would say, thousands of Wiseco and Diamond and J&E pistons, and they seem to hold up extremely well for us. We've been real pleased with them. But we don't use the piston as it comes directly out of the box. We have a lot of preparation to do to it. The first thing we do on the dome piston is we radius the domes. On the intake eyebrow, we lay this area back, and you can do this with a small hand grinder and cartridge rolls, and we just break the sharp edge on the exhaust eyebrow. We then just put a slight chamfer around the top land of the piston, and then we mask the ring grooves off and glass bead the top. It's just an appearance type thing, but it kind of cleans up the piston.
And
makes
also
it
for hot spots that you could have for sharp edges in the piston.
right. These sharp edges, if you don't roll them off, you will create hot spots, and this is a big problem in alcohol burning motors. These motors will detonate extremely easy, and I don't know whether they can zoom in or not, but you can see this top ring is awful close to the top of this piston, and if you have any hot spots here, it will start to lift the ring land. So be sure and do a nice job of radiusing off the dome of the piston, and then like I said, we glass bead it and it just kind of dolls everything up. Now about the pin bores. This piston here, as you can see, the wrist pin is extremely high. It's already up into the oil ring. Alright, when you get a wrist pin this high in a piston, the operating temperatures of the wrist pin goes up extremely. These pistons, as they come, do not have any way to oil them. And we prefer, I don't know whether the camera can get in here or not and see it, but we have put a small slot in the wrist pin bore. And we do this on each side of the pin bore. On each side of the piston there's a small slot in there. We do it with an end mill. You can do it with a hand grinder if you have a very steady hand. But you just need a little trough in there to hold some oil. Because if you don't, the pins are going to gall and they're going to stick. And they may eventually knock the spiral locks out, or it may even break the piston. Another thing that must be done, and this is all part of our preparation on this pin bore, is the oiling clearance. These pin bores generally come small, and we're going to hone the pin bores out new at 9/10 of a thousandths clearance. And on a rebuild, we can touch the pin bores up, and as long as they don't go over 1 4/10, you can reuse them. If your clearance exceed 1 4/10 clearance, we highly recommend reconditioning the pin bores and going to an oversized pin. Now these pins are available in 1/1000, 2/1000, and 3/1000 oversizes. Now on your Wiseco and Diamond pistons, they have oil holes already in the pistons, and I don't believe we can get a shot of that for you, but the oil holes are already there. They come in from the ring lands on the oil, and then they are cross drilled through the pin bore. But just make sure they're there. If something happens and they weren't there, you're going to have a problem. Now, about the spiral locks. That's the only way to hold the wrist pin in the piston. And when you buy your pistons, they're going to come with spiral locks. They're kind of difficult to put in, and you just about have to destroy them to get them out. We don't recommend reusing them over. If it's an emergency situation, be very careful about taking them out so you can reuse them. But normally on every rebuild we always put in new spiral locks, because if one of them came out and the pin drug the wall, it's going to be mighty expensive to repair. Now on the skirt clearances, every piston manufacturer has his own recommendations, and we follow them quite closely. Wiseco recommends 4/1000 minimum clearance, and their clearance is specified right here at 1.3 inches down from the oil ring. They specify 4/1000 clearance, and that's what we run on our motors, whether it's a gas motor or an alcohol motor. And we will run these pistons up until 8/1000 maximum clearance.
Why don't you tell them why we can run them tighter than basically a Diamond or a J&E?
Alright, we can run the pistons, the Wiseco pistons, tighter mainly because of the type of aluminum they are made out of. And these pistons hold up extremely well. A lot of people cringe when we tell them that we run 4/1000 clearance, but this is what Wiseco recommends, and we've probably used, I would say, at least 50 or 60 sets of them in the last 2 years, and we haven't had a single one scuff the skirt yet. And the tighter you can run the piston in the cylinder, the more stable the piston comes, and the less wear effect it has on the rings. You have to believe that the piston rocks in the bore at top dead center, and the more clearance it has, the more it can rock. and as that piston rocks, it's wearing on the rings, and it's also wearing on the block. But the Wiseco pistons run extremely well. We haven't had any problems with them, and they are quite readily available. We also use a lot of diamond pistons, and diamond's been around for quite some time. They run 7/1000ths out of the box new, and their clearance is measured a little bit higher at the center line of the pin. Now, we have also run probably, I don't know how many sets, hundreds of sets of diamond pistons over the last few years, and we haven't had any skirt failures with these. And we will continue using these pistons up to a maximum of 10/1000ths piston to cylinder wall clearance. And last of all but not least, I mentioned J&E, and the main reason why J&E manufactures a lot of pistons for us for what we call specialty applications, being our 428 cubic inch motors and our 435 cubic inch motors, plus sizes. These big alcohol motors are pretty hard on parts, and J&E will manufacture these pistons at just about any size or specification we want. This particular piston is for a 4130 bore. If I called them up and told them I wanted some pistons made for a 4133 bore, they would make them also. And they make these pistons on special orders, where Wiseco is not into the big cubic inch pistons. They don't like to put the wrist pin this high, so we just go to J&E for our big alcohol motors, and the pistons hold up quite well. We're real pleased with them. Now, J&E also makes pistons for 355s. They make them for the 9-to-1s, but our best experience has been with the 9-to-1s. We like to use the Wiseco or the Diamond, and then when we get into the big cubic inch motors, we use the Diamonds and the J&E.
Just give them a little idea on the rod when it fits in these big bore pistons that you got to clear it.
Yes, that's another good thing. A lot of times we'll get these pistons, like I said, we use a 6-inch rod, and you won't even be able to get the rod up into the piston to put the wrist pin through. On this piston here, I've had to mill out through the bottom here to get piston to rod clearance, and this is something that you'll have to check to make sure the rod does not bind against the dome of the piston. Now, as far as maintenance, there's no weekly maintenance to your pistons, but on rebuild, we always remove the rings, and first look at the ring lands very carefully and make sure that the rings aren't real loose in there. It may have started pulling a ring land up, so give them a quick little visual when you pull them out of the motor. We then take the ring lands off and we glass bead the dome of the piston, and we'll also glass bead the skirt of the piston. And what this does is it helps refinish the aluminum, and it gives a little surface for the oil to hold to. And we'll then take a Scotch-Brite pad and we'll actually Scotch-Brite the surface of the piston. And this gets it ready for reuse, and plus the glass beading also helps bring the piston back in size. The pistons they don't really shrink so much, but they get wore down, and glass beading the surfaces kind of helps resize the piston. And then last of all, you want to look in the bottoms of the pistons. Now, we Zy-Glow them, which is a chemical kind of a chemical crack detecting, but if you'll look real close, look for cracks down in around the pin bore area. They may come through the pin bore, they may be down around in here, but look real close, and if you see any cracks develop, it's time to throw the pistons away. Now, we have some motors that the pistons have run well over 2,000 and approaching 3,000 laps, and I would say at probably the end of 3,000 laps it's going to be time to replace them anyway, and the block's going to have to probably be refinished to the next oversize.
This part of the video we're going to be talking about valve train components. Camshafts, types, selections, lifters, rev kit, push rods, rocker arms, and related hardware. Alright, John?
All right, first in all our motors we use what is commonly known as a roller camshaft. I can't imagine any class of unlimited racing where you would have anything but a roller camshaft. There's not really much to be said about them. They're all made on steel bar stock, and their life is almost unlimited, providing you don't run the motor out of oil. As far as selection, there are several grinds available. As a matter of fact, there's hundreds of grinds available. And every application, what type of racetrack you run at, might require a different camshaft than for somebody else. And also the size motor that you run will determine what camshaft you're going to run. Whether you're going to run a 9-to-1 motor or an unlimited compression motor. Also whether you're going to use gasoline as a fuel or alcohol as a fuel. And our best recommendation as far as camshafts concerned is to call either Bruce or myself, or call your major cam companies. And currently we use a lot of Cam Dynamics products. We also use a lot of cams from Crane Cams, and we also use camshafts from John Reed Cams in Decatur, Georgia. Now, one reason why we use a lot of Cam Dynamics components is they are on the East Coast and we're also on the East Coast, and therefore product availability is real good for us. We are living on the West Coast, say out in California area, you have Crowler and Iskenderun, and I'm sure there's quite a few others out there. But it's better off to let them help you make the correct selection, because they get a lot more feedback from racers and engine builders like us, and those guys can help you make the proper selection. When we get on to lifters, on your roller lifters, there's actually two styles that we use. The first style I'm holding up is called a horizontal bar roller lifter. Now this lifter is manufactured by Crane and Cam Dynamics, and they also supply this lifter to a lot of other companies. But this lifter, the unique thing about it, this is called a rebuildable lifter, and we recommend after approximately every 1,000 laps to have this lifter rebuilt. And what they're going to do, there's small circlips in here. They're going to remove these circlips. They will change the axle and the roller and the needles. They will also magnaflux the lifter housing, and they are going to measure its diameter to make sure that it's not collapsed or you don't have too much clearance between the roller and the main body. There is another style of lifter. I don't have one laying out here, but perhaps you've seen them before, where it is a horizontal bar lifter. Let me see if I can find, I'll see if I can find one and show you in a minute. It's a horizontal bar. It has two springs in it, and it's kind of a spring-loaded type lifter. Those lifters are also manufactured by Crane and Cam Dynamics, and they are also rebuildable. And those are currently the only two lifters we will use. They cost a little more money initially, but the big thing being they are a rebuildable piece. Getting on to the rev kits. Rev kits are designed to keep the lifters in constant contact with the camshaft. The rev kits, this particular lifter takes this style of rev kit assembly. This goes on top of the lifter, and then you have an aluminum bar. Somebody's picked mine up. Aluminum bar that runs underneath the cylinder head that holds tension against this spring and holds about 50 pounds of pressure against this roller lifter to the cam. Now this will enable the engine to RPM a little higher, but the big thing is it keeps the lifter in constant contact so that the lifter doesn't try to float off the cam and it starts hammering on the roller follower. On push rods, we also use them from Cam Dynamics. There's a lot of different people that make push rods. These are made out of chrome moly steel, and they're hardened to run with guide plates. Now you have guide plates in your heads, which we're going to cover in a moment. You have to run a hardened push rod or it will cut the push rod in two. Now The push rods are also available in several different lengths. They make them 50 thousandths long, 100 thousandths long, and 150 thousandths long. And we're going to show you at the end of this tape in our final assembly tips on how to determine which push rod length you need. Now on your rocker arms, before you can attach the rocker arms to the cylinder heads, you're going to have to install what we call the screw-in studs and the guide plates. This guide plate I'm holding up here aligns the push rod with the rocker arm, and you'll have your two screw-in studs going through and holding it down on the cylinder head. The rocker arms we currently use are manufactured by Crowler, and these are stainless steel units. They are virtually bulletproof. Now these are available in several different ratios, and depending on our camshaft selection, we'll either run a 1.5 or a 1.6 rocker. And sometimes we will juggle rocker arm ratios being 1.6s on the intakes and 1.5s on the exhaust. Some camshafts that we use 1.5s throughout the motor, and some camshafts we'll use 1.6s throughout the motor. So when you make your camshaft selection, find out what rocker arm ratios you're going to be using. Now, on with the other related hardware. The last thing you're going to need once you have your rocker arm on the stud, you will have some type of an adjuster. And we prefer to use an adjuster that works in the conjunction with a stud girdle. Now the stud girdle has more than one function. First of all, it locks the adjuster more precisely, but its biggest thing is it keeps the rocker arms from flexing in the cylinder heads. Now a lot of times guys have run engines and they haven't run a stud girdle. They may have broken studs, or they may be breaking adjusters, and this is why, because the stud's flexing. This also ties all the studs together, and it makes your valve adjustment more steady, and it's a real easy piece to use. Now for some of you guys that are perhaps building a motor and haven't bought any of these components, you do have one other alternative, and that's to go with a Jessel rocker system. And on that system we have a bar that is attached to the cylinder head, and for every cylinder there is a pair of rocker arms that bolt down to this bar. Now with this type of setup, you don't have any screw-in studs, you don't have to worry about guide plates, you don't have to worry about adjusters, and you don't have to worry about a stud girdle. So if you haven't bought any components, you may want to look at this. The price of all the screw-in studs, guide plates, adjusters, rocker arms, and stud girdle is very comparable to the purchase price of this. Now, some of you have the newer style heads from Brodix where the intake rocker must be moved over. About the only thing going is the Jessel rockers, because the rockers are positioned over for push rod alignment. Is there anything else you think we need to add?
Nope. This part of the video we're talking about timing chains and gears, types, selection, preparation, gear alignment, thrust washers, and in play. All right, John?
All right, first of all, the type that we use in all our motors is manufactured by Cloy's. Just put that anywhere. The Cloy's double roller, which is called a true roller timing chain and gear set. It's easy identifiable from the other roller chains because the gear is wider, and plus your crank gear is going to have a 3 keyway index, so you may advance or retard your camshaft. Now we're not going to talk a lot about degree in the cam right now, but the only modification we do to this gear right off the bat is the dowel pin hole. We drill this out to 405 thousandths so that it will accommodate an advanced bushing. We do not use the gear to alter the cam relationship to the crankshaft. It's far easier to change the bushing than it is to pull the gear off. Now, as far as selection, the only time you might have to select something different is if your block has been align bored and align honed several times and perhaps the chain is extremely loose. You can buy these chains in shorter lengths, and they are available direct from Cloy's, and a few of the other major parts houses, speed shops may handle them, but they do make shorter chains. On preparation, another thing, we install the crank gear first and then install your camshaft gear on the block, and we want to check the alignment between the two gears. In other words, we want the gears to be perfectly parallel. We don't want the cam gear out in front, or we don't want the cam gear behind. Now, a lot of guys overlook this, and they may be breaking timing chains and they're blaming it on the chain when it's their own assembly fault. Now, the way to correct this is remachining the back side of the cam gear or remachining the back side of the crank gear. Now, the easiest fix, if the cam gear is running behind the crank gear, is to install a thrust washer, which we use on all of our motors. And fortunately, on most of the bow tie blocks, you will find that if you install a 30,000th thrust washer, install the cam gear, and install the crank gear, you will find that the alignment is just about perfect. If it is not, you may have to machine off the back of the gear in 30,000ths to accommodate this thrust washer, or you may have to machine off 20,000ths, but take the time to measure it, because the gears that are out of line can cause early timing chain failure. Another thing we use is a thrust bearing that rides in the middle of the gear up against the end of the camshaft. Now, this is to keep the cam gear and the camshaft from walking in and out of the motor. As you know, on a Chevrolet, there's no retainer plate to hold the cam back in the block, so we have to hold the camshaft against the thrust washer, and we like to have approximately 1 to 2 thousandths in play. Now, this is easily accomplished after you've put your cam gears on and it's all degreed in and you have your thrust button up here. You'll take your timing chain cover, and we have modified this one slightly. We put a little indentation in the end of it here. And this is easily done in a press. And you can see where this thrust bearing has been running against the end of this cover. And we now position this on the motor. And before we put our timing tab on, it goes on with it, we put a generous supply of silicone right here, and that keeps this tab from vibrating, as a lot of guys on their dirt motors have come in to check their timing and found that perhaps it is broken off. So if you'll put a dab of silicone there, it'll keep that pointer from vibrating. And anyway, after you put your cover on, the next item that goes on is your water pump. Now, we have water pumps that are supplied to us from Howard Stewart Engine Components, and they have built onto them what's called a cam stop, and that's this adjustment right here. We make sure that the cam stop bolt, where it comes through the back of the water pump, clears the front cover, and that none of these bolts touch the front cover, because we only want this bolt to touch the cover. And after bolting the water pump onto the block, we're going to run this screw in till it touches the front cover. And once it meets the front cover, we're going to start checking the in-play of the camshaft. We're going to go through one of the lifter bores with a screwdriver and a dial indicator on the back of the camshaft, and we're going to continue threading this screw in until the camshaft has approximately 1 to 2 thousandths in play. At this time, we will lock this lock nut down and then recheck the camshaft in play. Now, you have to do this because if you don't, and the camshaft continually walks back and forth in the engine, it's going to vary your timing at your distributor or magneto, and it's also going to cause unnecessary wear on this thrust washer and possibly unnecessary wear on the end of the block. And another little item that some guys may run is a roller bearing assembly that will fit behind the cam gear. These also work real nice. They're a little harder to work with. You have to do a little bit of detailed machine work to make this fit back here. But if you buy one of these roller bearings, it does come with instructions. It doesn't come with any insurance. It's going to come with some instructions that will tell your machinist how to machine the back of this gear in a lathe. And probably last of all but not least, I want to talk about the bolts that hold the cam gear on the camshaft. Use them one time and don't reuse them again. For the $2 or $3 that this cost, if one of the bolts was to break or come out, it's going to cost several $1,000s to repair the motor. And be sure and use this plate. Now this plate has a hole in the end of it here for the dowel pin from the camshaft to stick through. Do not do that. I want you to run the dowel pin over here. Let this plate hold the dowel pin in place. It'll hold the bushing in place. That way the bushing nor the dowel pin can come out. We had one 9-to-1 compression motor running this year that unfortunately that dowel pin came out of the end of the camshaft. Not only did it cost the customer several $1,000s in repair because it bent all the valves in his motor, it ruined the timing chain and gear set, but it also cost him $2,000 purse money because he was leading a race. And that pin doesn't care if you're leading or running dead last. If it comes out, it's still going to do $2,000 worth of damage. After we degree the cam in, we'll have our degree wheel on the front of the motor, and we're going to show you this later. Before you take the degree wheel off, turn the engine to 38 degrees before top dead center and go in behind the flywheel flange of the crankshaft and run a bolt in there and lock the crankshaft down to the block so it can't turn. Now remove your degree wheel and put your harmonic balancer on. Now the harmonic balancers that we use, we buy from Chevrolet. Some of them we use as are, others we turn down smaller diameters to clear rack and pinion steering in the Asphalt cars where they lower the motors down extremely. We degree the balancers for the first 40 degrees and then every 90 degrees. And the reason why we degree them this way is it's going to help us check our piston to valve clearance that we're going to cover in some of the final assembly tips. But the reason why we want to put the balancer on now, we've got the engine at 38 degrees, which is where we're going to run the timing. When you put the balancer on, don't hammer it on. Use a puller, pull the balancer on, and we want to make sure that your timing pointer, the 0, aligns with the 38 degrees on the balancer. If it doesn't, rework the pointer so that it does, because you may not be running 38 degrees timing. You might be running 40, you might be running more, you might be running less. So this is just a little tip for you to do so that you know your timing is running correct. Is there anything else we need to cover on this, Bruce?
Covered everything. This part of the video, we'll be talking about oil pans, type and fitting of the oil pan. All right, John?
Naturally, all of the engines that we build, be it for short track dirt or asphalt, we run exclusively dry sump oiling systems. So you have to purchase a dry sump oil pan. Now, currently, probably the absolute best state-of-the-art oil pan is offered by ProCam, and they're located in Michigan. I unfortunately don't have one here that I can show you, but they have some very well-designed baffles and scrapers inside the pan to pull oil off the crank and make it return to the pump quicker. When you have all that oil inside the crankcase, it's trying to slow the crank down, and with their scrapers in there, it's actually pulling the oil off the crank and giving the pump a better chance to pick the oil up and pull it back to the dry sump tank. Now this particular pan here is made by Hamburger. Now when we talk about the fitting of the pan, I'm not concerned right now with the fitting size on the lines, but the pans do need some additional work before they'll clear the rods. So you want to put the pan on the block without a gasket and make sure that the rods nor the crankshaft hit the oil pan, and then put your gaskets on and seal the pan down. Now as you can see on this particular oil pan, we have it fitted to our 428 cubic inch dirt motor, which has a 4-inch stroke and Corilla rods. And you can see where we've had to notch not only right here, but we've also had to notch in right here and dimple the pan back in these 4 locations. And also on the other side of the pan, we've had to do a little minor work to get the rods to clear by here. So sometimes it does take quite a bit of time to get these pans to fit and clear the rods. Now in the case with the ProCam pans, when you order one, you can specify not only the chassis that you have, but also the stroke of the crankshaft and the connecting rod type. And they have mock-up motors at their facilities, and they will adjust your oil pan where it's going to fit probably right out of the box. Now you may have to do some minor work, but all of their scrapers inside the pan will unbolt and come out. Now this is so you can clean the pan better, but it's also if you need to lower the scrapers or if you need to raise them a little bit, it's very easily adjustable. It's a very nice piece. They do cost a little extra money, but in the long run, they're worth it.
This part of the video we're talking about cylinder heads. Type, selection, preparation, valves, titanium and steel, springs, retainers, locks, and lash caps. Alright, John?
Okay, first of all of our engines that we build, we use the Brodix aluminum cylinder head. I can't think of trying to race with any other head. There are other aluminum heads out there. We currently build very few motors with cast iron heads that run in unlimited classes. Brodix has been around longer than anybody, and their castings are really quite good. And getting on with the selection of cylinder heads, Brodix makes several different heads as far as they make what's called a -8, 9, 10s, 11s, and now they're making 12s. And what we're talking about when we mention these numbers is their intake runner volume. In other words, if you took this cylinder head, put an intake valve in it, filled the intake runner, or CC'd it I should say, you will come up with a CC reading. The 8 heads are bigger than a 9. The 9 is the smallest. The 10s are bigger. 11 is bigger yet, and the new 12s, I believe, are over 220 cc's. Now, when you decide what cubic inch motor you're going to build, you can call Brodix and they will recommend which cylinder head you should have. We currently use 8s on our 9-to-1 motors as well as our dirt motors, and we also use 10s and 11s on the bigger dirt motors. We've used a few sets of 9s on 9-to-1s, but we've had better luck using the 8s. Now, if you have some cylinder heads and don't know how to identify them, by the exhaust port will be a number. Now these heads, the number has been ground off, but there will be a number right here, and it will either be an 8 a 9, 10, or 11, or 12. Now these heads here were 8s, but the guy chose to grind the number off. So unfortunately on this head I can't show you, but that'll give you an idea of the different heads that Brodix has available for our small block Chevrolet. Now, when I speak of preparation, I'm talking mostly about the port work, and we have all our heads professionally prepared. The list of people that port these heads could fill a book. We get them from Clement's Porting Service. You can buy them from Diamond. You can buy prepared heads through Prototype Engineering. You can probably buy prepared heads from Baker. There's a lot of people that offer prepared cylinder heads. And for the guy at home without a flow bench, I'm not saying he's wasting his time, but he's better off leaving this to a professional that has the flow bench to test his results. As far as valve jobs and all, we run a 45-degree seat, approximately 60 to 80 thousandths wide on the intake, and 80 to 100 thousandths wide on the exhaust. We run the seat out to the maximum diameter of the valve size. On most of our motors, we run a 2050 intake valve and a 1-inch 600 exhaust valve. Now on some special applications such as a 9-to-1 engine, we have run a 1-inch 575 exhaust valve, and on some of our big dirt motors we'll run a 1-inch 625 exhaust valve. But we found that the 2050 intake valve has done about the best job for us. As far as a top angle cut, somewhere in the neighborhood of 30 to 38 degrees, a 45-degree seat, and a 60-degree bottom cut. And after reconditioning our heads, we like to go in with a cartridge roll and blend in that bottom cut of 60 degrees. We'll blend that back into the port. We'll then take our new valves and we will lap the valve in. As you can see, I have the seat right out to the edge. We lap the valve in, and then I will put the valve in the valve grinder and I will back cut the valve, and this is called our back cut angle right here. We have found the best angle being 23 degrees on the intake and 30 degrees on the exhaust. Now we arrived at these figures with using the flow bench in the dyno. Now there may be some angles that might be better for other heads, but what we found with our small block Chevrolets and the Brodix heads, that 23 on the intake and 30 on the exhaust have given us the best gains. As far as stem to guide clearance, you need to run, a good rule of thumb is 2 thousandths on the intake and 2 thousandths on the exhaust. If you're running steel valves, you can run the intakes a little tighter than that, but if you're going to run titanium valves, you have to be careful because titanium itself is a poor bearing material, and the stems will wear out if you try to run them too tight. Now the only difference between a titanium and a steel valve is the actual weight. And when we run a 9-to-1 motor, which run in the 78 to 8200 RPM range, we like to use the titanium valves because it's lighter, it's easier on the valve springs, and because of the valve acceleration rate with the particular camshafts that we use in the 9-to-1 motors, the steel valves really tend to hammer on the seats bad, and we've just had better luck with the titanium valves in the 9-to-1 asphalt motors. In the dirt motors, we've been using this steel valve here. It's manufactured by Horatio O'Farah Engineering. You can buy them direct from Horatio O'Farah in Fort Lauderdale, and we're going to give you the number on this. It's a fairly inexpensive valve, and we've had several of these valves run over 3,000 laps. We recommend replacing them at about that time. Fortunately, we've never had one break off. It's a nice made piece. It's got a chrome plated stem, and they are available in standard length and 100 long. and a lot of people may not know as to why they need a 100 long valve. It has to do when you install the valve in the cylinder head and you go to put your retainer and locks on, you have to measure what is called the installed height, and that is from where the spring or spring cup is going to set to the bottom of the retainer. Now the springs that we're currently using come from Diamond Racing. It's a number 3315 spring, and we install this spring at 1 inch 850 thousandths installed height. It gives us between 165 and 170 pound seat pressure. We use this spring on our 9-to-1 motors as well as our dirt motors. If you do not have 1 inch 875 thousandths retainer to spring bucket height, you'll have to go with a longer valve, or you'll have to machine the spring bucket deeper. Now, a little more about the valve springs. On the dirt motors, we can get 2,000 laps on these springs, and they seem to hold up real well. In other words, we'll build the motor and rebuild it once and use the springs again. The third rebuild, we wind up replacing them. On the asphalt motors, the 9-to-1s that run in the neighborhood of 8,000 RPMs, we'll generally replace those springs after 500 laps. That's especially in the case of ASA and All-Pro racing, where they'll probably run maybe 300 laps on a Saturday afternoon, or 400, and maybe a total of 500 or 600 by the time the weekend's done. And these springs really take a beating, plus the temperatures get quite hot. So we had just soon replaced the springs, because a broken spring can relate to breaking off a valve, and that's far more expensive than the springs. Now, on the retainers and locks and lash caps, probably the absolute best piece is the Howard Stewart Super 7 retainers and locks and lash caps. Now, the reason why I like these pieces the best with the Super 7 retainers and lash caps, which you have to run on a titanium valve. You cannot let the rocker arm ride directly on a titanium valve. You must have a lash cap on here, and the lash cap will be a press fit on the end of the valve. It's going to actually press right on there. And with the Super 7 retainers from Howard Stewart, I can unkey the valve on the motor, and we're going to show you how we do this. We'll unkey the valve on the motor, we take the retainer off over the lash cap, then we can pull the spring off, put the new spring on, put the retainer on, compress it, put the lash caps, or excuse me, push the valve locks back into place and not disturb the lash cap, because it's very difficult to remove at the racetrack. You also have one other alternative, is this lash tip. Now what you have to do to use this piece is put the valve in a lathe and drill a small hole, and this piece is now going to press in the end of the valve and become a permanent piece. And you don't have to remove this any longer, and you don't have to run a lash cap with it, as the rocker arm is going to now ride directly on this hardened surface. And then the last thing we want to discuss on our cylinder heads is what CCs do they have to be. And in our final assembly tips, we're going to show you how to calculate compression ratios so that you can determine what CC heads you need and just how close the CCs have to be.
This part of the video we'll be talking about intakes, types, and selection. John?
All right, currently we're using 3 different manifolds on our motors. We're using 2 of them that are offered to us by Edelbrock, and the third one comes from Holley. The ones that we probably use the most of being this Victor Jr. It's manufactured by Edelbrock. We use this on most of the smaller cubic inch motors and the 9-to-1s. up to probably 370 cubic inches. When we get into the bigger motors, we use the Edelbrock 4+4 manifold on engines all the way up to the 435 cubic inch range. The third manifold I mentioned, which is the Holley Strip Dominator, I don't have one of them here to show you. Those manifolds work real well on the big cubic inch motors, running from 400 to 435 cubic inches. Now, to show you the difference between a Victor Junior and a 4+4 is the plenum depth. On the Victor Junior, it is approximately 3 3/4 inches deep, whereas with the 4+4 manifold, it is approximately 4 inches deep. So you have a little more plenum area for fuel storage. Now, when you get a Holley manifold, if you choose that one, that manifold is almost an inch taller yet. And we're going to talk about carburetor spacers when we get to the carburetor section. So this is pretty much going to cover it for the manifolds, the one we use, the Victor Junior, the 4+4, and the Holley Strip Dominator. Now, as far as porting these manifolds, once again, with our cylinder heads, we generally order the manifold from the porter also and just specify which manifold we're going to use. They have the talents and the equipment and the knowledge to develop the manifold for our particular application. And the only thing that's left for us to do to the manifold before we can put it on the engine is the front of the manifold has to be cut out here to clear our oil fitting that's going to be in the front of the block. And if you run a water line kit on the manifold and cylinder heads, you have to cut a notch in here to clear this water line. And other than that, they're ready to go.
This part of the video is on valve covers, types, and breathers. All right, John?
All right, first of all, there's only one kind of valve cover to use on an engine, and that's one made of aluminum. We stay away from the steel ones or the thin stamped aluminum ones because the heat tends to warp them, the gaskets get out from underneath them, and you just have all kinds of problems. And I've seen more guys drop out of the racetrack from a leaking valve cover gasket, and there's just absolutely no excuse for it. This valve cover here is manufactured from B&B products. It's a nice heavy aluminum construction. It comes with the breather tubes already installed, and they have a nice little baffle in them so that oil doesn't blow back out through them. The valve cover is notched at the top to clear the intake runners, and it's got a nice gasket retention area to hold the gasket in place. And on this particular valve cover, we're running it on a motor with Jessel rockers, and we've had to grind some additional clearance here. So once again, when you take a piece out of the box, when you bolt it onto your motor, make sure it fits, because you don't want to damage any of these pieces. The valve cover breathers that we use are manufactured by K&N. This particular breather has a shield on it to shield the heat away from the headers. These breathers, when you buy them, they'll come with some oil that you can put on them. These are reusable. You can wash them, and as long as the heat doesn't start to deteriorate the sealing ring here, they'll last a long time. The only other thing you need to do to your valve covers, it can be on either side, is you're going to have a vent line fitting, and you're going to have to vent your valve cover to your dry sump tank. Now, some people will run a vent on the tank separate, and that's okay, but we prefer to vent the tank to the motor. It just seems a little better way to go. So, and as far as valve cover gaskets, we're going to cover a lot of things on the gaskets, but while I'm right here, Felpro makes probably the absolute best valve cover gasket. It's got metal sandwiched in between cork, and you can reuse this thing probably a full season, and the cost is quite justifiable. And you can tighten these valve covers down extremely tight, and you won't have any leaks whatsoever.
Okay, dry sump up? Yep. I've always got a spare dry sump up myself. So how you want that? You can try Bartlett. You can burn them too.